Hello, good evening. Today is Friday, February 5th, 2021, and I'm continuing with my recorded video presentations of my lectures and talks in cybersecurity and data science, in particular at the intersection of cybersecurity and data science. I'm Bhavani Thuraisingam from the University of Texas at Dallas, and I'm the Founders Chair Professor and the Executive Director of the Cybersecurity Research and Education Institute. I started recording these presentations last year in 2020, starting around May of 2020, when we started working from home for COVID-19. And I've continued to give these recorded presentations. Typically, before I give a keynote address, I record the presentations and then post it on YouTube. I also give talks on various other topics related to cybersecurity and data science. And also, this is under my YouTube channel. I've got two channels, and one will be technical presentations, and the other channel on motivational presentations, motivational talks. And so they are both under my name. And so the second channel, also, I've just recorded one presentation. I believe it was made on January 3rd, 2021. That's a motivational presentation. And back to my technical presentations, the last presentation that I recorded was, I believe, on December 31st, 2020. So this is the first presentation, technical presentation for 2021. Okay, the title of my talk today is Access Control in Database Management Systems. This is sort of almost the very first topic that we focus on when we study, secure database systems, and that is on access control. Right, that's sort of the most basic of security measures. In fact, this semester, I'm teaching a class on data and application security and privacy at the University of Texas at Dallas. And so this was one of the classes I taught last week on January 29th. So my lectures are on Fridays in the afternoon. So I just finished my lecture at around close to 7 p.m. So now it's about 8:15, and so I'm going to record this presentation. And again, thank you very much for listening. And now I'm going to share my screen. Okay, and yes, why is this? Hold on a second. Okay, now it's better. I think it's still a bit of a problem. I think I'm going to put this down here. So, okay, so this is better. Okay. So the title of my presentation, Access Control and Trust Management, they're all based on policies for data management systems. So you can also think of them as database systems, okay? And today is February 5th, 2021. Okay, so the outline of my talk, I will first talk about discretionary access control in relational databases, in particular what we used to call security constraints, but now they are known as security policies. And then I will discuss non-discretionary access control, and in particular, mandatory access control, which is multi-level database management system. And I've already given a lecture based on multi-level secure database management systems sometime last year in 2020. Then I will also talk about role-based access control. And this will also be discussed, mainly be discussed under types of access control. Then I'll talk about different types of security constraints, which are now known as security policies, the various types of access control, including inference problem, role-based, temporal, usage, RBAC, attribute-based access control, and so on. And then talk about policies and trust management and some directions. So I would like to thank several people, in particular, Professor Ravi Sandhu from University of Texas at San Antonio and his team. He provided me with some charts several years ago for a joint project that we had on role-based access control and usage control. It was funded by the Air Force. And then I would like to thank Professor Elisa Bertino from Purdue University for the charts that she provided on trust management and policies. And in particular, we had some joint projects also with the Air Force Office of Scientific Research. And so I've sort of modified their charts to present some aspects of this presentation. And of course, I've taught the class data and application security and privacy. I add privacy in parentheses because the name of the class is data and application security, but we also talk a lot about privacy. And so I first started teaching the class in 2005 at the University of Texas at Dallas in spring. And so I've been teaching it from 2005 to 2014, so for around 10 years. And then I'm teaching again this semester because my colleague is on sabbatical. He teaches this class right now. Anyway, and I've also taught variations of this course at AFCEA, Armed Forces Communications and Electronics Association, at some of their mini tutorials or mini courses they have at the AFCEA's TechNet, and I think I taught this in 2005, and to various organizations, in particular Department of Defense, that was since 1990. So I've been working in this field starting in 1985 fall, so over 35 years. Okay, now access control in databases, right? So 1975 to present. So access control policies, they were mainly developed initially for file systems, such as reading and writing, read-write policies for files, read, write, and execute policies. So and so can read, or a process can read into a file, another process can write into a file, a process can read or write into a file, or execute a file. So access control in database systems really started with the work in System R and Ingress projects. So remember, relational data model was developed in 1970 by COD, and then System R by IBM Almada and Research Center, in particular Jim Gray was one of the pioneers, and several others have worked. And then Ingress at UC Berkeley, pioneered by Professor Michael Stonebreaker. And so these two systems have really given us so much. System R has eventually evolved into DB2, and Ingress then became a commercial product, and I believe it was sold to Computer Associates. Anyway, so these two systems came up with access control rules. They were defined for databases, relations, tuples, attributes, and elements. And System R really pioneered the SQL, which is now a standard structured query language, which is now SQL. It's a standard language to query relational databases. And there are several variants of SQL have been developed for different technologies. And then Ingress developed a language called Quell. It was more logic-based language. And these languages had statements like granting access, revoking access. So these statements have been extended over the years. And so we came up with various sort of our initial work on policies. It was actually, I think, both System R as well as Ingress, they came up with security policies. So read access on employee. So for example, policy or constraint that we used to call read access on employee to user group A is granted access, provided the salary is less than 30,000 and the department is not security. So user group A does not get access to those salaries greater than or equal to 30,000 and the department equals security. So query modification, I believe, was also developed around that time by System R and Ingress researchers. And more recently, it's been called query rewriting. What we do is modify the query according to the access control rules. And so if you want to retrieve all employee information, say user group A wants to get that information, then of course, only the information where salary less than 30,000 and department is not security can be retrieved. Okay, so that's query modification. So this is sort of access control in database, relational database systems in a nutshell. So, and again, that work started around 1975 and it still continues. So query modification algorithm, and more recently it's been called query rewriting. So input is a query and access control rules or policies, and the output is the modified query. So what's the algorithm? Given a query queue, examine all the access control rules relevant to the query. And then what we do is introduce the where clause in relational structured query language SQL to the query that negates access to the relevant attributes in the access control rules. So example, the rules are John does not have access to salary in employee and budget in department. The query is to join the employee and department relations on department number. Modify the query, then what do, right? So you want to query, so John does not have access to salary in employee, budget in department. You want to find all the information in employee and department. So you've got to join on department number is the common attribute. So modify the query to join employee and department on department number, and then project on all the attributes except salary and budget, because John doesn't have access to salary and budget. Output is the resulting query, and then the modified query is posted against the databases and the results are given to the user. Okay, so mandatory access control, and then if you look at my talk I gave, multi-level secure database systems last year, it is 1982 to present. So there was a lot of work on multi-level security for operating systems in the 1970s and early 80s. Then 1982, the Air Force summer study convened, the Air Force convened a summer study, and they came up with various strategies to design and develop relational database systems. And that's how I got involved at Honeywell in 1985. So just very briefly, so we looked at the Bella Padula security policy, right? You read at or below your level, and you write at or above your level. So users are granted security clearances and data is assigned security levels, data or files. So Bella Padula mandatory security policy states that you read at or below your levels. Top secret cleared user can read top secret, unclassified, secret, confidential, all the data, but the top secret user can write at or above his level. So top secret or above. So there's no such thing above top secret. So for instance, a secret user can read data at the secret, confidential and unclassified levels. He or she can write at data at the secret level or top secret level. Because again, there's a lot of things going on, because the reason that you don't want to write below is because the process could be malicious. So if the process is operating at secret level, it has access to secret data, and unless it's trusted, it can write secret data into unclassified files. But if it writes secret data into a top secret file, it's okay because it only has access knowledge up to secret level. But the problem here, not a security problem though, you pop something into a top secret container and then later you cannot read what's in the container because a secret user cannot read. So what we have done for databases is, because databases, you can make sense out of the data, there's semantics. So you read at or below your level, and then you write at your level, a restricted form of the write. And the granularity of classification is entire databases could be classified, relations, tuples, attributes, elements, and so on. So number of security architectures, and again, my previous presentation goes into a lot of detail. Operating system can provide the access, mandatory access control. So DBMS is untrusted. So DBMS runs as an application. So all of the database data has to be decomposed and stored into operating system files, secret files, unclassified files, top secret files. And so DBMS could be untrusted from security point with respect to security. Operating system is controlling all the access to files. And then later on, you can recombine all the data, after the query is posed and give the results to the user. Okay, so good thing about this is that the database management system is untrusted, and so the operating system can do all the work with respect to providing mandatory access control. But the problem is DBMS is untrusted. So when it recombines the data, it can make errors, right, with respect to integrity. But with respect to security, we know that Bella Padula is strictly enforcing all the security policies. So you cannot read anything above your level and you cannot write anything below your level, right? So those are the advantages and disadvantages. Trusted subject-based architecture, database is trusted with respect to mandatory access control. So for going back here, the first design, SRI, International's CView project, it was a sister project to our project. So they were developing based on mandatory operating system providing access control. Second design, trusted subject-based architecture. The database is trusted with respect to mandatory access control. That means so earlier design, remember we said database was untrusted. Operating system provides all the access control. But in the second design, a part of the database is trusted and it's providing all the access, right, to the data. So TRW's AST views are based on the trusted subject-based architecture. But the problem with this trusted subject is that part of the database has to be trusted because that's the part that is controlling access to the data. It's not relying entirely on the operating system. And MITRE Corporation developed, another design was based on integrity lock architecture. So what happens here, very briefly, you have a untrusted front end, data goes in, then the trusted front end will compute a checksum based on the data and the security level, and then store the checksum with the data at the back end. Later, when you query, it retrieves the data, the level, and the checksum. It recomputes the checksum to see whether they are both matching. If both checksums match, that means it has not been compromised, and so the data is given to the user. If not, then there could have been a problem, at least from an integrity point of view. There could also be a problem from a security point of view. So MITRE Corporation developed a couple of prototypes. One was based on the Mistress prototype database system. Another, they developed it based on the Ingress system. So that's number 3. The number 4th design was distributed architecture. And what you do here is you separate the data according to the levels. So you have a database system which is running at unclassified, another database system running at secret, another database system running at top secret. And there are 2 designs. The first design, you strictly separate the data according to the security level. So you have an unclassified database, a secret database, a top secret database. And so if a user is unclassified, goes straight to unclassified. User is secret, it can go to the secret and unclassified for query, just to the secret for update. Top secret, we can go to all 3 databases for query and only the top secret database for updates. But the problem is a secret user's query is going into the unclassified database. So there could be some covert channels here. So what we do is replicate the data. So all the unclassified data is replicated in the secret database. Together with secret, and all the data is replicated in the top secret database. But there's a less of a problem from a security point of view, but still a tiny problem, because all the updates have to be synchronized. As a result, there could be some signaling channels, but not as bad as when you partition the data. So there's a partitioned approach, distributed approach. And the Naval Research Laboratory developed a system called Sintra based on this design. And then, of course, the design I was involved with, and that is Honeywell's lock data views. It was designed to work on top of the lock, highest security rating, A1 operating system. We pretty much followed the CView approach, operating system providing mandatory access control, but we also extended it for problems like inference and aggregation. So there's a part of the architecture that is trusted and a part of the architecture that is not trusted. So it's, in a way, it had the best of both worlds. Okay, so these were the designs for mandatory access control. And as I said, a previous lecture went into all the details. So I'm going to focus more on discretionary access control and non-discretionary, which does not have anything to do with mandatory access control. Okay. So the next topic, security policies, also access control rules. So what are the types of policies? So as part of the locked data views, we came up with some highly innovative approaches for policies, such as simple policy, John cannot access attribute salary in relation employees. So our policies was mainly based on multi-level security, based on security clearance and so on, but we can adapt it also for discretionary. So John cannot have access to attribute salary, content-based policy. If mission contains information about mission, say in the Middle East, then John cannot access mission. So I shouldn't sort of mention a specific country, but I just chose Middle East. It could be Europe, it could be Asia, it could be Australia. Association-based constraints, ship locations and missions taken together cannot be released by John individually. Each attribute can be accessed by John because in a way, our names, our healthcare records and our names together, right? Individually, maybe you can show individual names or healthcare records, but the identifying attributes or identifying identifiers have to be removed or not shown. Release constraint is after X is released, Y cannot be released. A typical example is that after you release the last 4 digits of your social, you don't want to release the first 3, because if you do, then the person can try to figure out, put different combinations for the middle 2 numbers and be able to compromise. Aggregate constraints, 10 or more tuples taken together cannot be accessed by John. So the entire phone book, right, could be classified, but you can give out some individual numbers. So here we are saying 10 rows, information about 10 people. Less than 10 people can be given, but not 10 or more. Dynamic constraints after the mission, then the mission can be accessed by John. So for instance, when Osama bin Laden was killed, everything was kept top secret. But as soon as he was killed, then the government released the information. They downgraded it, right? So these are the policies. So we have developed a policy processing system. It was highly innovative in the 1990s, and we developed a patent, and the patent has got numerous citations. I was checking recently, but this was designed for multi-level database systems. So if you listen to my presentation, again, my earlier presentation, it goes into a lot more detail. So what we are saying is we have a database design tool that's designing all the schema according to certain policies. So you want to use those policies to design your database. And then you want to enter your data according to certain policies into the appropriate tables. But what we are most interested in is this query processor. So the policies are stored, security constraints, the policy manager or constraint manager. A user poses a query, and then the policy manager is consulted, looks at all the policies, modifies the query, and then poses the modified query, and the result is given to the user. Okay, so that we implemented it, but it was far more sophisticated, meaning that we implemented release policies. When something is released, you cannot release something else. So we maintained a history database to see what has been released. So we had a lot of interesting variations of this particular architecture, which, as I said, which we patented, a complete system. Okay, so now we finished some of the main parts on policies, as well as query modification and the mandatory access control. Now I want to talk about some of the other types of access control. One is inference problem and access control. So inference occurs problem when users pose several queries and get the authorized responses. And based on these authorized responses, they deduce information that is highly classified or highly sensitive, right? So inference problem occurs when users pose the queries and deduce unauthorized information based on the legitimate responses that they get. Security constraint processing for controlling inferences, right? So that's what we did. So essentially this architecture I explained earlier, it handles inferences as well. And more recently, there's also work on controlling release information instead of controlling access information. So for instance, famous professor Geo Wiederhol from Stanford University came up with very interesting approach. So he said, instead of doing inference problem during the access, when you access the database, let's focus on doing it, doing it during processing the policies during the release processing. Okay, so that's inference. Then temporal access control models incorporates a time parameter into access control. Like for instance, after a certain time, certain things can be accessed, things like that. Role-based access, and we'll go into somewhat detail on role-based access control, depending on your role. If you're a professor, you are granted some access. If you are secretary, you're granted some other access. If you're a student, you're granted some other access. If you're administrator, and so on. So roles. And this role-based access control, known as RBAC, has been implemented in many commercial systems. Then there's also positive and negative authorizations. Should negative authorizations, so John does not have access, should that be explicitly specified? And how can conflicts be resolved? Right? So for example, I'm going to show you the next chart. So temporal access control, after January 2022, only doctors have access to certain medical records. Role-based, manager has access to salary information, project leader has access to project budgets, but he does not have access to salary. What happens if the manager is also a project leader? Typically, you give the principle of least privilege. The least privilege a person needs to do his job. Positive and negative authorizations. John has write access to employee. John does not have, it's negative, is John does not have read access. John does not have write access. And again, how can conflicts be resolved? You follow the principle of least privilege. Okay, so now we finish the different types of access control. Now we're going to delve into it a bit further in terms of policies. Need to know versus need to share. RBAC, UConn, ABAC, release and dissemination, risk-based access control, and then I go into trust management and some directions and so on. Okay, major conferences for policy and access control. So one by one, need to know versus need to share. Before 9/11, right? So especially during the Cold War, before 1989, we're very concerned about our secrets being stolen. So we enforced a strict need to know. Even if you had top secret clearance, you don't just get all the data unless you have a need to know, depending on your job. So first thing is, does the user really have a need to know? But after 9/11, there was an emphasis on need to share, because they said, I don't know whether it's true, but the 9/11 Commission report, and also everyone was saying, if only the FBI and CIA had shared the data, okay, of all these terrorists. And so we don't know. It's always easy to say, right, after the fact. But again, there was a lot more emphasis on need to share. In fact, I've done a lot of work on securely sharing information. Do we give the data to the user and then analyze the consequences? Because if somebody really needs the data about this person, do you give the data and then worry about the consequences? Or do we carry out some kind of a risk analysis, right? Do we analyze the consequences and then determine the actions to take? Or do we simply not give the data to the user? What are the risks involved, right? If you don't share, then we have a problem. There could be an attack. But if you share, right, some secrets could be violated. I remember when I was teaching a class at the Armed Service Communications Electronics Association, FCA, there was one person from the DOD, he said, if I don't share the information, I won't get punished. But if I share the information and I share the wrong information or classified information, then I would get fired. Okay, so there's still a lot of need to know a culture, but what is the balance, right? I don't have the answer. The policies have to determine what to share, right? It has to be determined at the policy level. And if policy says share, then you have to share. That's how we have developed our prototypes based on that. Okay, so RBAC, this is the invention of Professor Ravi Sandhu who is now at University of Texas, San Antonio, together with NIST researchers, National Institute of Standards and technology. So access to the resources are based on the roles, right? Access based on roles, professor, secretary, and so on. Access to information sources, including structured and unstructured data, both within the organization and external to the organization. Hierarchy of roles. So you have the employee, you can have president and secretary and engineers and specialists and so on. Engineers could be electrical engineers, civil engineers, and electrical engineers could be control engineers and so on. So hierarchy of roles. How do you handle the conflicts, right? So there should be conflict resolution roles, control, dissemination, and sharing of the data. So the data has to be disseminated and controlled. That's very important. So here are the pictures that Professor Ravi Sandhu provided to me. So you have the users. Users can, depending on the sessions, one session I can have some access, another session I can have some other access. Users all have roles, and roles have permission. Permission assignments come with roles. A president role has these permission assignments, secretary roles have these permission assignments. And the administrative roles, there are also administrative roles, right? What are the administrative folks can do? And there are administrative permissions. And all of this is a role hierarchy. All of this has to have to work together, right? Sessions, depending on roles, and administrators assign the roles to the users. And then users, depending on the roles, have the permissions. So all of this, they have to work together. Okay, so that's RBAC. Then Professor Sandhu said that RBAC was, there are some things that you can't do with RBAC, right? So RBAC, so he said, let's expand it. What about the usage? Because sometimes like phone cards, as you start using it, then the value drops. So here he was setting the stage for ABAC, attribute-based access control. So RBAC model is incorporated, he has incorporated into UCON, usage control, useful for various applications like authorization. But then he also had obligations. Obligations are actions required to be performed before an access is permitted. So what are the obligations can be used to determine whether an expensive knowledge search is required? Like, for example, before you access something, you are obliged to do certain things, right? You are obliged to check with some people, so these are the obligations that you have to fulfill before you are granted access, right? Or you have to maybe sign some forms or something like that. Attribute mutability used to control the scope of the knowledge search. So again, as you use the attribute, right, the value is going to change. That he incorporated. Conditions can be used for resource usage policies to be relaxed or tightened. Like, I've got to pay my fees before I take the class. What was interesting, although RBAC was for resource usage, it has been expanded. In fact, ABAC uses some of the concepts of UCON, which is, RBAC is role-based, is very popular, and ABAC is extremely popular now. And UCON was sort of extension to RBAC, and some of it has gone into ABAC. Okay, so for instance, it's the RBAC, right? Rights and subjects and authorizations and objects. Then he has extended it with, he and his student, obligations and conditions. You've got to you've got to meet your obligations before you are granted access, and you've got to meet certain conditions. And then mutability is that before usage, pre, and then ongoing, you use it, and after using it, your phone card value has dropped, right, after you use it. And then at a certain time, you may not be able to use it at all. So that's the UCON, usage control. Then we have this ABAC. So UCON didn't really take off, but RBAC is extremely popular. But RBAC is very much organizational centric. Almost every commercial product like Oracle and so on have implemented RBAC. But now we are entering into a cloud web services world, right? So it's an open environment. Then came attribute-based access control, and NIST has made it into a standard. And Ravi Sandhu has also contributed quite a bit. Several people have worked on ABAC. So the idea here is that the users have credentials, right? I have the credential of being a professor, and somebody has a credential of being a secretary or being a parent or being a president. User is granted access based on his or her credentials. Policies specify the access to the resources based on the user credentials. Access could include accessing the data and resources, getting a job, getting entry into a building. So it is sort of expanded from just simply accessing the data. Users' credentials are verified first and then access may be granted. And XACML, Extensible Access Control Markup Language, is the access control language and the protocol for access to resources. And SAML, Security Assertions Markup Language, is the protocol for identification and authentication. So with SAML and XACML being applied to web services, being applied now to cloud. And so RBAC is sort of the access control model now for cloud and web services. And perhaps even IoT, Internet of Things. Okay. Another type, remember I mentioned release and dissemination. So up to this point, we talk more about the access control, controlling access to something. But what about release? Release policies will determine to whom to release the data. So what is the connection to access control? Is access control sufficient? So once the data is retrieved, according to the access control policies, you should still decide, should I still give it to the user? Can I release it to the user, right? That's where release policies come in. So if you have released A, can you release B? And dissemination is that once the data is released, then there is dissemination under conditions, right? I release it to you, but do not disseminate. And again, for electronic music, digital watermarking, right? People just disseminate the records, the music and so on, but they don't know there is a watermark there. You can put it through the watermarking tools, and then the digital signature is there, then they know that you have copied it. So pirated software, pirated music, and so on. So you've got to be careful. So these are release and dissemination policies. Okay. So another thing, as I said, after 9/11, a lot of interest on bringing in risk. What are the risks involved in releasing, disseminating, accessing? Risk models should be integrated with the access control, release, and dissemination. Simple method, you can assign risk values, right? If I release this information, the risk is 0.9, very high. If I release this information, this other information, risk is very low, 0.001. Simple method, as I said, assign risk values. Higher the risk, the lower the sharing. What is the cost of releasing the data? And the cost, risk, and security are closely related. Remember, I have talked about, if you listen to my presentation on big data security and privacy, we talk about an optimization framework with respect to cost and optimization and so on. So the cost, risk, and security closely related, okay? So we want to minimize the cost, we want to minimize the risk, and we want to maximize security. They are all trade-offs. If there's no risk, then we don't have to worry about security, but there are risks. Okay, now I come to trust management, and some of the information that I'm going to present for the next few charts are those that Professor Elisa Bertino shared with me. So she gave it to me as part of our joint project that we had. So I'm going to use more or less her charts, but I have also modified some of them. So for instance, you have trust management. So even if you can share everything, do you trust the person? Even if you have granted access control, release, dissemination, can you trust? What is the person's reputation? That's what trust management is. And how do you manage this trust? Trust services are identity services, authorization services, reputation services. And then you've got to negotiate, right? So you may have some credentials. You may have to send your credentials. You can ask the other party to send his or her credentials. And then you've got to disclose what your policies are. The other party will have to disclose what his or her policies are. And then we computer scientists, we have to design these trust systems and trust management policies. So we have had to come up with an appropriate language, a logic-based language, or maybe based on XACML, semantics constraints and policies. And then there are some system requirements like credential ownership, validity, alternative negotiation strategies, and privacy. So all of that have to be taken into considerations, and some very well trust negotiation systems. I would say, I think there was one Keynote, I don't know who the developer is, And TrustX, a very good system from University of Milano, Elisa Bertino and her team, and Trust Builder from University of Illinois at Urbana-Champaign. So these were some of the early breakthrough trust management systems. Okay, so how do you negotiate trust between two parties? So here we have client and the server, and how are they negotiating trust with each other, right? So the client is requesting from the server, give me some data, some resource. So the server will say, these are my policies. So I will not give out your social security number, but I might give out your address or your area code, okay, your zip code. So if I agree, the client sends its policies, right? Once you give me the data, I will share it with my spouse or my mother or my child, but not with everyone else, not to anyone else. So once all the policies are agreed, then the subject, the server will send the credentials authorized and stamped by some credentialing authority. These are my credentials. I'm highly reputed. And so client will, because how do you know, even though they say they're not going to give you a social security number, can you really trust? So the client will send the credentials to the server, and then if everything is agreed, the resource is granted. Now, this is not necessarily the order. You can exchange credentials first and then the policies, right? So that's what we are saying here is you are credential ownership, and then digital credentials are exchanged, and then the policies are exchanged. Okay, so here is the problem: establishing trust in open systems. So we are talking about an open environment where strangers are communicating, not a role-based access control sort of system within an organization. So conventional systems, we have user ID and password. User identity is known in advance, and it can be used for performing access control. In open systems, sorry, the spelling, participants, P-A-R-T-I, may have no pre-existing relationship and may not share common security domains, okay? So what do we do? So we have, let's see, a person, is sitting and trying to, do identification, authentication. We have to mutually authenticate between two people, just like I showed between the person, the access control, the user and the client and the client and the server, they both have to mutually authenticate. Assumption on the counterpart honesty no longer holds, right? So we've got to look at the digital credentials, and both participants need to authenticate each other. So the trust negotiation model, promising approach for open system where most of the interactions occur between strangers. The goal, establish trust between parties in order to exchange sensitive information and services, right? The approach, establish trust by verifying properties of the other party. So I gave an example earlier, how to verify the properties. And here's an example, another better example. So interaction between strangers in open systems are different from traditional access control models. Policies and mechanisms developed in conventional systems need to be revised. So conventional systems, we have user IDs. Now we have subject properties, our credentials. And here we have access control policies controlling access. Now we have to disclose our policies. These are my policies, right? Rather than the access control policies. So for instance, so this is what I mentioned, remember? We said, no, in the previous chart, right? Establish trust by verifying properties. Just because I say that I am a US citizen and so on, that information has to be signed by the Department of Homeland Security, right? Whoever grants me my citizenship or whoever grants me my driver's license, it has to be signed by them, right? Verified. So that's the situation here. So okay. So here is a case where, let's see, I think I talked about, no, sorry about that. Let's see. So I finished this, right? Now we talk about digital credentials. So assertion about the credential owner issued by certificate authority like VeriSign or Global Sign, right? So that's a CA, certification authority. They will give you, so whenever you apply for a certificate, they will sign and send you That means you cannot say, you cannot just make it up. You've got to show that it's signed by the other person, by the certificate authority, and then you can decrypt it by the public key or something of the certificate authority. So it's got to be digitally signed. Each entity has an associated set of credentials describing properties and attributes of the owner, but every part has to be able to be verified. Okay, so here's a person like Alice is a machine, right? Julie is applying for a job and she's an American. So that means that part has to be verified by company A. And then, right, so Julie is married, so want to know the marital status, and then the digital credentials, 3 kids, married and American. So maybe she's going for a babysitting job. So they would prefer someone, maybe a domestic person who is married with some children. And so you look at all the credentials and then ask, say, company A to verify from credential user and company B to verify whether she's married from the credential authority. And once all the information is given back to Alice, then Alice will say, okay, Julie can have the job, right? So all the credentials have to be specified, have to be presented. Okay, so how can you specify these credentials? They can be expressed through security assertion markup language, SAML. SAML allows a party to express security standards about a given subject, authentication, attribute statements, authorization, decision statements. So there has to be a language for different people to communicate each other. And the global language that we are using, SAML, which is an XML, extensible access control extensible markup language, XML, and XACML is an access control. So SAML is for credentialing and authentication and so on. XACML is for access control. They are both based on XML. Okay, so last few charts, the disclosure policies, they govern access to, so you have to disclose these policies to get access to protected resources, access to sensitive information, disclosure of sensitive credentials. So you have to disclose your policies before you are granted any access to anything. Disclosure policies express trust requirements by means of credential combinations that must be disclosed to obtain authorization. And again, as I mentioned, Professor Elisa Bertino and her team were the pioneers for trust management. Okay, so here's an example that Elisa presented to me. Disclosure policies, the example, suppose there's a bank called NBG Bank offers loans to students. To check the eligibility of the requester, the bank will ask a lot of information. You can't just walk into your bank and say, look, give me a loan, right? So here we want access to a loan, not the resource, not data, access to a loan. To get the loan, you need to have a student card, an ID card, a social security card, and maybe financial information, either a copy of the federal income tax or a bank statement. Okay, income tax return or a bank statement. And I think the student card and ID card are more or less the same. I think maybe you may not need all 3, but let's see. So policy P1 says you need to have a student card for student loan. Okay, so here we are assuming student and ID card are the same. Policy P2 says you need a social security card for student loan, right? Plus P1, plus a student card. Policy P3 says you need a federal income tax return and a social security card. As a result, a student card, all 3. Policy P4 says, because this P4 is not about income tax return, it's about bank statement. Show a bank statement, then you need a social security card and a student card. So if you have either P1, P2, P1, P2, P3, then P5, you get the loan. Or P1, P2, P4, then you get P5, then you get the loan. So these policies result in 2 distinct policy chains that lead to disclosure, 1, 2, 3, 5, 1, 2, 4, 5. Okay, so this is an example where you are presenting the policies, right? They're disclosing your policies to get access, and the access here is the student access to a loan. If you want access to a building, maybe you may have to do the same thing. Access to anything, right? Maybe even a marriage license, right? You need to have all of the tests all completed and all the credentials you need to present, right? So all of that, anything that you need access to. Okay, so now we come to the last chart. I don't know how long I took. So policies are of much interest to many organizations. I started calling it constraints, and as I talked about more recent topics, I changed to policies. Policies are of much interest to many organizations and applications. It could be healthcare, defense, intelligence, banking, financial, medical. Again, I'm repeating healthcare, retail, and manufacturing. Almost anything is according to policies. There are roles and responsibilities, and we want the policies to be flexible, right? Not be rooted in sort of, not static, where as the world changes, the policies are going to change. Again, as I said, the fact that Osama bin Laden was killed, before his killing, everything was top secret. After that, it was unclassified. We talked about RBAC, UConn, ABAC, trust negotiation, dissemination policies. Before that, we talked about query modification, various types of access control. And we also talked about need to know versus need to share, and excellent references to understand about access control policies. There used to be an IEEE policy workshop. I believe it started around 1999 and finished in 2012. I attended a couple of workshops, in fact, gave a keynote address at the 2007 policy workshop. And then ACM SACMAT, that's a conference, Symposium on Access Control Models and Technologies, 1995 to present. And I've been quite active with SACMAT, especially since around 2003, 2004. I've given keynote addresses a couple of times, I believe, at SACMAT. In 2004, presented a number of papers. I also chaired SACMAT in 2007. And also, I was very honored to get the Test of Time. That's a 10-year most influential paper award from SACMAT in 2018 and 2019, back to back. 2018 for a paper I published in 2008, and 2019 for a paper I published in 2009. So these are the directions for policies, and this is a topic that's not going to end, right? Started with discretionary, non-discretionary, mandatory, RBAC, UConn, ABAC, you name it, and trust policies and information sharing policies. I haven't even finished everything. How organizations share data, and what we believe. And so I'm going to now finish this presentation, and it says I'm going to stop sharing. Okay, all these, oh gosh, what? Okay, so what I want to say is that policies are governing almost everything now. And so I've given some talks. If you look at my presentations given last year, I've talked about policies for information sharing. So one of the things that myself and Professor Bertino and Professor Murat Kantajlu, my colleague, we've done some work on policy-aware data collection, policy-aware data sharing, policy-aware data storage, policy-aware everything, right? So anything that we do, what we are saying is that policies have to govern whatever we do, and especially for not only for security, in particular for privacy too, because whatever we collect, data collection, right? We cannot be just randomly collecting everything without letting the person know, right? For instance, before I record a session, before I teach, right? I am obligated. Is it obligation? I don't know. We talked about obligations. So I have to tell the students. It's not even I must tell the students, you are being recorded, right? Sort of a privacy policy. So policies govern data collection, policies govern data manipulation, data storage, data access, data sharing, data analytics. So policy-aware data management, policy-aware Internet of Transportation Systems, policy-aware Internet of Things, policy-aware cloud. That's the way we are going, right? The world is, sort of moving towards that, because we need that for security as well as for privacy. And of course, you've got trust. So CPT, security, right? Or confidentiality/security, right? Disclosing secrets. Privacy is secrets when it comes to you, right? Sensitive information, personal information, and then trust, because you need to be able to trust the person. Even if the person can get the data, you need to be able to trust. So that's one key point. Another key point that I want to make is that we are living in a post 9/11 world. And so the whole challenge for us is sharing, information sharing versus like need to know versus need to share. And I'm finding, I wrote an article back in 2004, data mining, national security, or data mining, counterterrorism, privacy, and civil liberties, right? 2002, very concerned about 9/11 and terrorism. So now our biggest worry is COVID-19, right? Well, not that terrorism is not there. We've got to be concerned about terrorism as well. COVID-19, so last year I wrote, 2020, I wrote a paper, data science. Of course, data mining has now evolved into data science. So it's data science. And I talked about data science, COVID-19, right? Privacy, data science, COVID-19, privacy, and civil liberties. And it's very interesting when you compare the two, how there are a lot of similarities. There are also many differences. So I've also, especially the COVID-19 privacy, civil liberties, I do have a presentation. I gave a keynote address, as I mentioned, at the IEEE Big Cyber. So that's also on my YouTube presentation, on my YouTube videos. And so, and again, I think this is the end of my presentation. I've got a very long evening. I was all afternoon, I was teaching for close to 3 hours. And then I thought, I might as well give this record this presentation as well, because it's a very interesting topic, and it's a topic that's never going to end, because as technologies are developed, there are more and more policies. Oh, one more thing I wanted to mention. Many of the policies I discussed, they are what I would call more TOY, T-O-Y policies. Why? Because I'm a computer scientist. I'm not a policy expert. So we work with policy experts, and I work very closely with Professor Jennifer Holmes. She's a dean of our economics, policy, and political sciences. I work with her, and she's excellent. She's one of the top experts in policy. So their job is to come up with realistic policies. So we've got to work with policy experts, with privacy advocates, with security experts, with technologists, with data management specialists. We all have to work together to solve this problem and to make this world a better place and a safer place. With that, I will stop there for today. Good night, and stay there. Please be safe. And please be motivated, because there's so much that we can do even now while staying at home and working during the era COVID times. And hopefully we'll all come out of this strong, and we can continue to do our work and keep ourselves motivated. That's the most important thing. Thank you very much.